The research paper explores the adaptability and generalizability of large language models, LLMs, in domain-specific tasks, particularly ontology learning. It questions whether LLMs truly adapt to domains and reason over semantic relationships or simply leverage lexical senses and their frames. A controlled experiment was conducted using WordNet to synthesize parallel corpora, including English and gibberish terms, for two ontology learning tasks: relation extraction and taxonomy discovery. The results indicate that off-the-shelf LLMs do not consistently reason over semantic relationships when adapting to gibberish corpora, instead relying on senses and their frames. However, fine-tuning improves LLM performance on lexical semantic tasks, even with domain-specific terms unseen during pre-training, suggesting the applicability of pre-trained LLMs for OL. The study highlights the challenges of LLMs, including susceptibility to hallucination and limited generalizability to unknown domains, emphasizing the need for further research on these aspects. The paper also presents comprehensive experiments on popular LLMs to assess their performance on relation extraction and taxonomy discovery tasks. 3 synthetic datasets were created by turning domain-specific terms into gibberish, simulating the adaptability and generalizability of LLMs in unseen domains. The results show that there is a limit to the generalization capability of off-the-shelf LLMs, especially for tasks that leverage lexical semantics. However, in-domain fine-tuning improves in-domain task-specific performance, and these improvements are transferable to new domains. The paper discusses related works in ontology learning with LLMs, in-context learning, and domain adaptation, highlighting the significance of fine-tuning and the limitations of off-the-shelf models. The authors of the research paper investigate the adaptability of large language models, LLMs, to specific domains from an ontology learning perspective. They propose an evaluation pipeline that involves corpus preparation and LLM evaluation, starting with the creation of a parallel corpus of terms and definitions in the form of gibberish. This is achieved by using the English WordNet to generate a parallel corpus of concepts and definitions, where the concepts remain the same up to an input label mapping. The authors then evaluate the LLM on 2 tasks: relation extraction and taxonomy discovery, each on both versions of the corpus. They expect the results to be analogous since the concepts remain the same. Additionally, they investigate the effect of fine-tuning on the in-domain performance of LLMs. To simulate a domain that is unseen for the LLM, the authors generate another knowledge graph where the domain concepts have gibberish representations and definitions that do not collide. This is achieved through a 3-step procedure: concept mining, concept linking, and gibberish generation. The authors use this pipeline to test the adaptability and generalizability of off-the-shelf LLMs, and to investigate the effect of fine-tuning on their performance. The results of this evaluation will provide insights into the ability of LLMs to adapt to specific domains and perform well on unseen data. The paper also discusses the adaptation of LLMs to domains from an ontology learning perspective, presenting a novel approach to evaluate LLMs' ability to adapt to new domains by creating gibberish representations and definitions for concepts within a domain. It proposes an off-the-shelf evaluation methodology for assessing LLMs' performance in 2 lexical semantic tasks: relation extraction and taxonomy discovery. The performance of the LLMs is then compared across these 2 cases to determine if they truly adapt to the new domain or simply rely on lexical senses. The authors investigate the adaptability of large language models, LLMs, to arbitrary domains and unknown vocabularies, focusing on ontology learning. They propose fine-tuning experiments to assess the effect of fine-tuning models on inference performance for taxonomy discovery tasks. The fine-tuning experiment involves training LLMs on instructive datasets with a prefix prompt, where the model is asked to identify whether a statement is true or false, given a pair of concepts and their definitions. The authors generate synthetic domain-specific datasets from the Open English WordNet to evaluate the performance variation with domain specificity. The fine-tuning experiment shows a significant performance decrease when replacing real terms with gibberish in both relation extraction and taxonomy discovery tasks, suggesting that LLMs are better at leveraging semantic priors but struggle with unknown words. The study highlights the importance of considering the completeness and quality of the ground truth datasets and concludes that off-the-shelf LLMs are not sufficiently suitable for ontology learning tasks, particularly in the case of relation extraction, and that further research is needed to improve their adaptability to different domains. The authors investigate the adaptability of large language models, LLMs, to new domains from an ontology learning perspective. They conduct experiments on taxonomy discovery and relation extraction tasks, comparing the performance of various LLMs on real and gibberish corpora. The results show a significant performance drop when LLMs are tested on unseen words, indicating they do not reason over semantic relationships. However, fine-tuning LLMs on specific tasks and domains improves their performance drastically, suggesting they can adapt to some extent. The study highlights the limitations of off-the-shelf LLMs in ontology learning tasks on arbitrary domains and demonstrates the importance of fine-tuning for improving their performance. The authors also propose an experiment to test the transfer learning capabilities of LLMs, which shows that LLMs can perform ontology learning on arbitrary domains with effective pre-training. Overall, the research emphasizes the need for further development in leveraging reasoning with LLMs for ontology learning. Here is a combined summary of pages 17-20. Large language models, LLMs, have demonstrated impressive capabilities in adapting to new tasks and domains, achieving state-of-the-art performance in various natural language processing tasks. However, their limitations in domain adaptation are also evident, often relying on pre-training corpora that may not be representative of the target domain. To address these limitations, an ontology learning approach is proposed, where LLMs learn domain-specific knowledge and adapt to new tasks and domains. This approach has shown promise in ontology matching and alignment tasks. The authors highlight the importance of evaluating the performance of LLMs in domain adaptation tasks, emphasizing the need for standardized evaluation benchmarks and metrics. They also discuss the emergent abilities of LLMs in adapting to different domains, such as developing reasoning abilities through chain-of-thought prompting and improving in-context learning through symbol tuning. Larger language models have been observed to perform in-context learning differently, leveraging domain-specific knowledge to enhance their performance. However, it is crucial to consider the limitations and assumptions of these models, including their reliance on large datasets and potential biases. Future work should focus on further understanding how LLMs adapt and how their abilities can be leveraged for real-world applications. The authors emphasize the need for a comprehensive understanding of LLM's capabilities and limitations to develop effective ontology learning approaches that can adapt to specific domains and tasks.